Okay, yeah. So my name is Simon. I'm based in San Jose these days, and I'm working with the function packs built on top of NSO. One of these function packs is the NFVO, Network Function Virtualization Orchestrator. There you go. Took me 2 years to learn that. I'll just quickly go through what an NFVO is because I'm guessing many people have heard it, but just a super fast crash course is that it's the orchestrator part of the Mano stack. This is the Mano stack, the Cisco NSO version of the Nano stack. I'll go back to that one. But in short, it's a way to onboard something called descriptors, which are blueprints for VMs, basically, and their connectivity with each other and the network service they are trying to create. And it's also a service to instantiate these virtual machines, as well as react on events from something called a VNFM, which is a lifecycle management part of the Nano stack, which makes sure that the VM is up and running, and if it dies, reacts on that and notifies the NVO, which in turn does something about it or notifies someone above us, northbound of us. Yes, and the way we do that is using a plan, so using the NSO plan functionality. Yeah, this is the Etsy stack. I'm not going to go into this, but this blue part here is the NVO part. We're talking with something called a VNFM, which in turn talks talks to the Vim, which is usually OpenStack or VMware or something like that, which actually spins up the VMs. This is kind of an old product. We've had it for three or almost 4 years in different iterations. Before we went live with version 4.0 that came 2 weeks ago, the design looked like this. It's oversimplified, of course, but I think it will get the point through. So if you actually worked on it, you'll probably disagree with some of the designs that you'll see here. But the VNF info, that is, think of that as the service. That's somebody instantiates a VNF info. So that has a plan and the service code. When you do that, we create a kicker that looks at operational data somewhere. That's being written by something that will redeploy our service when something happens in the system. And then we have a CDB subscriber waiting for something to be written to the VNF info. And then we copy that to an internal service. The reason why we do this, and this is the big flaw in the design of the old version of our NVO, is the stage delete problem. Everything works fine when you create the VNF info and waits for the VM to come up, but when you want to delete it, you might want to do something before we tell the VNFM to actually delete the VM. You might want to revoke a license, for example. So the only way for us to do this was to create the CDB subscriber in between. So when you delete your VNF info, your service, we don't actually delete it. We don't do anything. We just allows you to delete your service, but we are actually not telling the device in the device tree to delete something. It will make more sense, I think, here. So let's go from the create case first. If you create your VNF info, we copy your service to an internal service. That service in turn talks to the VNFM, which is just a device in the NSO tree. And we have a netcom subscriber on that device or some kind of notification subscriber, depending on what kind of VNFM it is. And a notif subscriber in NSO. We get a bunch of events from the VNFM. The VM is alive, the VM is dead, the VM is being deployed or being healed or scaled or stuff like that. Whatever happens to the VM, the VNFM tells us. The notif subscriber writes operational data telling basically our service what happens, and the kicker redeploys our VNF info, and we update a plan to tell the northbound service what happens. And this is the plan that we end up with for a VNF info. It's a pretty simple plan. We have the init state and the self component that Tree talked about, and then we have this is the actual name of the VNF, and it's 3 stages. It's the init stage, it's deployed, and it's ready. Um, right, I talked about the CDP subscriber, and why we add that is of course because of the stage delete issue that I said. It's kind of a layered service, but it's not because there's the subscriber part. So you actually commit your VNF info part, and NSO just takes that and returns the commit the transaction and says everything went fine. Then we copy the service to the underlying service, and things could go wrong there. Maybe the VNFM isn't there, or maybe we get an error or something like that. But the user thinks that everything went well because the commit went through. So that causes some kind of confusion that I thought everything went well, but it didn't. And then you need to know where to look to figure that out. Okay, so the underlying service that is kind of hidden to the user failed for some reason. And the plan that you saw was kind of lackluster. It just had 3 states. They do their job, and I said lazy developers because we could have a really cool plan there, but we decided not to because I mean, we weren't forced to, so we didn't. We just had the 3 most important states. Uh, it's a pretty straightforward service. So then we go to the post Nano when we started doing the Nano stuff, and the reason somebody asked me in the break, why did you do this? And the main reason is the stage delete problem, the confusion with the CDB subscriber copying the internal server, the external service to something internal. Same setup here. You have a VNF info that the user creates. That's the service. It also creates a kicker to operational data, but this is no longer created by. Okay, I forgot to say that, but before we actually in the code created the kicker for the operational data. Now the Nano Services creates all the kickers for us, and it doesn't just create one kickers; it creates a bunch of kickers on different states. We also have a stack. Now we actually have a real stack service, and I'm not going to go into the details on why we have an external service and an internal service, but I want to get the point through here that there's no subscriber anymore. So if this service would this underlying service would fail, the upper layer would also fail. So your commit would fail. You would get immediate feedback that something went wrong. Again, it just writes data to the VNF M. And instead of having a subscriber, we use the notification kickers, but that's only a different way of doing it. But we wanted to use all the latest and greatest stuff in NSO, so we decided to do that as well. And instead of having a notification subscriber up top, we then have an action that reacts on the events it gets instead. But the idea is the same. It writes data to operational data, which kicks our VNF info and updates the plan, and we get a plan like this instead. So there's a bunch of stuff going on in the service that you didn't see in the older version of NFVO. But now you see that we don't only deploy and are ready, we actually are, sure, we are still deployed and ready, but we also create auth groups and we create interfaces, we apply some templates, and once the device is actually up and running, we fetch SSH keys and we do a sync from and we apply more templates before we are actually ready. So now all the things that if we were good enough developers could have written in the original service, but that we didn't, we're now basically forced to do. So you kind of get that for free, which I think is one of the benefits of Nano Services, that you are forced to create a good plan that describes what the service does. Kickers are created automatically. We got rid of all the CDB subscribers that we had. We get a very detailed plan and a dynamic plan. I don't really have slides on that, but I can try to explain what I mean with a dynamic plan, and that's the behavior tree that Tree was talking about. That in this particular version of the service, we onboard a device called VM, called Volvo brand something. We actually add that to device tree. But if you for some reason would change your service to not manage the device, we only wanted to spin it up, but we don't want to add it to the NSO device tree, you would change that, and this plan would automatically become a different type of plan, a different version of the behavior tree. And instead of having an onboarded device, we would have an unmanaged device to look at instead. And you wouldn't have a bunch of these states. We wouldn't care about fetching SSH keys or syncing from or applying any configuration, because we don't manage device. We just We don't configure the device. We only care of its lifecycle events. Yeah, and the Yang explains the service. So after some practice, you could actually just open the Yang file and kind of understand what the service does without going into trying to figure out where the templates are or where the source code is, where the Python code or Java code is. But we just move the logic. It doesn't really. We say that now you can write it in Yang instead of writing it in the code, but it still needs to be somewhere, and it takes a lot of practice to go from writing something in Python to try to take that logic of making decisions and put that into a Yang file with XPath. It's and the same logic needs to be there. The same if case that you wrote in Python is now instead expressed in an XPath expression. So you don't get anything for free, really. You just move it to somewhere else. I say it's much harder to debug. That's true. It's harder in a sense that when something failed in the old version, either the logs just told us about it, or we could, in worst case, go in and just do print statements in the code and try to figure out what happened. Just try to debug your service in a stupid but pretty effective way. But when it fails here, when you reach one state but not the next one, and there is no information anywhere on why it didn't reach the next step. It's just a big silence. There's nothing in the logs. There's nothing. There's no crash. There's nothing. You are not at the stage that you want to be, and it is really hard to figure out why am I not here. Probably your XPath expression is wrong, but XPath is only evaluated to true and false. And if it became false for some reason, it's you can't do print statement in your XPath to figure out why it didn't do what you wanted to do. Yes, XPath. So my last slide here is of one of these XPath expressions that, and this isn't the worst one. I just wanted to find one that actually fit the screen. And probably and NFO, it's a pretty advanced service, and it does a lot of checks in a lot of different places. But you do end up with XPath expressions like this, and I mean it's yeah, look at it. It's super. It's very hard to understand. It's very. I think it's Mundus who wrote this originally, but it it does a lot. And this we had the exact same logic in Python code, but then it was broken down into cool functions with good names and easy to follow structure. But here you yeah, it's kind of a mess. So in our examples, we show you a nice little XPath that just looks at a leaf somewhere, but this is probably what you will end up with after a while. And like I said, we have worse examples than this. Yeah, that's all I had for the journey of NFVO.
And do you want to take questions at this point?
Sure,
or?
I can take questions.
Okay, let me get.
Why we did do it? I mean, two reasons: the stage delete issue. We wanted a way to be able to backtrack. I didn't go through that here, but with this, we get the stage delete for free. We can have a delete precondition that says I won't delete the actual VM until something happens. The same logic we had in our stage delete with the CDB subscriber, but now we get it kind of for free. We don't have to write a subscriber that copies the information and tries to solve that for us. That was one of the reasons. The other reasons was to try it, I think. I mean, we have had the Nano Services in NSO for a few releases, and nothing had been done with it. So we wanted to see that we know it would be a good fit for NFVO. So let's see if it is a good fit. And it turned out that it was. And maybe I didn't highlight that enough, but I do think it's better than reactive fastmap once you get used to it. I think it's easier to understand once you ignore the XPath. Once you actually understand the breaking up of different states, and that each state has its own little snippet of code that it runs. You don't have to think about the returns in your code that you have with reactive fastmap, but you go a part of the code and then you return, and the next time you go through everything again and return at some other if condition further down. You only concentrate on your current stage in the code.
Okay. Any question? Okay, let's do it in the microphone.
One small question, something I didn't get regarding the kicker. Does it trigger something during the deletion process, or is it only, does it, I understood that it triggers a redeploy during the creation process.
Yes.
But during the deletion process, is the kicker useful, or what does he do?
Yeah, it's basically the same thing then. Then you have we create a kicker on the delete precondition instead.
Okay. Okay.
So if and try to evaluate that, and if that isn't fulfilled, we create a kicker for it.
Okay.
And once that is fulfilled, it will kick the service again and hopefully delete that state or component.
Okay. And one last question: when the service instance is deleted, all the kickers dies, or how? Are they still activated, or?
No. So the kickers are deleted once the precondition is met.
Okay, so they follow the life cycle of the service.
Okay. Yes, and if
Okay.
everything goes like it should when you delete the service and everything goes through, all the kickers are gone from the system.
Any other questions? Okay.
So now that we are using Nano Services for the NVIDIA packages, what's the minimum version of the NSO that we need to run the NVIDIA package on?
So I mean, so for the new version of NFVO, the requirement is NSO 5.1. But in theory, it could also run on 4.2.7 or something like that, because that's when they backported all the changes needed for running Nano Services efficiently.
Thank you.
Okay, I'll take it for you. Okay, Larry.
As far as debug, is there any XPath calculation output that you can look at?
So the question was if there's any XPath calculations to look at. Yes.
If you do like a commit details, you get a...
You can do that if you're lucky enough that the service goes to the point that you want it to. And you also have the XPath log, of course, but in our, I mean, if the service runs for an hour or so and you do a lot of stuff, that XPath log is, we're talking gigabytes of logs here. It quickly becomes really big. So it's very hard to debug in that. What was that? The kicker doesn't go into the XPath log, but the XPath expression calculation goes into the log. So yeah, it's really hard to figure out what kicker or what part, but you do see something, but it's hard to understand why.
And we have another question. Simon?
Sure.
Or, whoop.
There is something called progress tracing, that's for the part where you say when you are entering.
Let me do this first.
Yes.
Then you will see what expression with the precondition.
Can you repeat what you're saying? Try. I'll get on the mic.
Yeah. So there is one part that's called progress trace that is, I think it exists from 4.7 or even older, and that's used in Nano Services to show you what the convergence of the plan states are. But as the big problem here is that you have kickers that won't evaluate, so you won't get there. But there are something called, when you do a transaction anyway, you could set on debug tools and say debug kicker. Then you will see which kickers would possibly be invoked by this transaction, and were they or were they not. But that is for that transaction, so it won't follow the redeploy loop. So I think that we have to invent something that follows the service. Then we could possibly get something a bit better.
Yes.
And it's perhaps stating the obvious. I mean, this is the current state of the very unpolished features. I mean, it's not like we are saying, okay, it's hard to debug, we're happy, we're stopping it. This will be polished and fixed in the coming release.
Rebecca
So I
isn't
think
happy.
that's also why we did the NFVO stuff to sort of eat our own dog food, to understand what doesn't work well. So this is the very transparent thing, so we don't get the wrath of Rebecca.
We have the
Yeah, we already do.
Yeah.
Yeah.
And Simon, we have another question back here.
Yeah.
Could you speak close to the mic?
Yeah. My question is that the additional states which you are showing, like get fetch SSH keys and all those things, is it
coming from that internal service, or it is for us, the user, to define it in the Yang?
It's for the user to define in the Yang,
Okay.
but that's where it's defined. But you're forced to have some kind of state. If all these states does something, all these are a snippet of code that actually does something,
Yeah.
and you're required to write. If you want that to be, I mean, you could of course have just one state that did everything, but you're kind of forced to think in a new way where you actually break up your code in a more logical way, and then you always get a nice state for it for free.
So are there any restrictions or precautions which we need to take when we transition from one state to the other? For example, like I am spinning up a VNF, but am I allowed to actually check the state of a VNF2 before actually moving a state within VNF? Can we do complex like calculations within the state change?
Yeah, you can, but then you end up with XPath expressions like this.
Yes.
But that's what it is. Checking a bunch of stuff before you go to the next state.
Yeah.
So this is this is a precondition for something.
And the only possibility you have, you are not needed to have states that create config all the time. So
No.
if this is the only way you could partition this, if it's possible, is if there is some or something here that you could do two states and split that into two conditions. I wait for the first one to
Sure.
be met, and then I went for the other one to be met. Then you could. But the only thing you do is you're splitting something bigger into
Yeah.
smaller parts. But it's completely okay to have states that's just wait for something and then go further.
Okay. Yeah. Thank you.
Okay, thank you. Any other questions? One other back here.
Okay,
Or-
sure.
Go ahead.
So the plant data you showed is on the internal service. So if we were to troubleshoot the NVO package, is it the top service we should be looking at, or the internal version of the NVO info?
Probably both.
How is the top service like, or the internal one mapped to the top one?
So it's a stacked service. So the top layer creates the internal layer, and it's true that the advanced plan that you saw was on the internal layer. And the idea there is most of the time you don't need all that logic. You don't need to see all that. But if you are curious on why is something not happening, then that's a place to look at.
Okay, thank you. Any other questions? Wave at me.
One in the front here.
Oh, okay.
Thank you very much. So in fact, I have two questions. One question regarding the difference between RFM and Nano Services.
Mm-hmm.
So you explained the added value of Nano Services regarding mastering the deletion process.
Yes.
What about scalability in terms of kickers? If I have, I don't know, 10,000 of services, do you think I will have less kickers to manage or to handle with RFM or Nano Services?
I mean, with Nano Services, you will have more kickers,
Okay.
but you don't have to manage them.
Yeah.
They are created under the hood
Okay.
for free, in a sense.
Okay.
So
Thanks. Yeah. So it could be a criteria, maybe in the design. Not-
criteria in what way? That
Well, to select one or the other solution, implementation, one or the other implementation.
yeah, I mean,
or
I'm guessing people would say that you shouldn't go Nano Services unless you need them
Okay.
for some reason. But I would say that why not? Why not use it? If you know that you need a reactive service,
Okay.
why not do it in Nano Services? I think the benefits are greater than
Yes.
the drawbacks.
Okay.
And the number of kickers I wouldn't worry about that.
And one last question. It's regarding CI/CD and automating testing.
Okay.
Is it complex to design automated testing to test corner cases related to Nano Services?
No, not more complex than for an RFM at least.
Okay.
But you're saying that you want to be able to trigger all the different conditions and see that they're all met
exactly.
and all that.
To test the different branch of the code, and do you think it's a lot of workload and to design those tests, or
Yeah. There could be a lot of work if you
Okay.
want to explicitly go step by step for some reason and
Yeah.
see that stuff works
okay,
in the way you intend.
okay.
But it's but again, not more complex than. Yeah, fairly similar.
Okay.
Exactly the same issue. Yeah.
Okay. Okay.
So that the problem is still there
Okay.
or moved
Okay.
again.
Thank you.
Okay, maybe time for one or two more questions, and then we'll have to wrap. Anybody else for a question? Okay,
I just want to say one thing about Nano Services that maybe didn't go through in is that I think our salespeople usually brag about NSO is able to, you can write services now without a single line of code. You can do everything in templates. And that was true before, but with Nano Services, you can do that and also have a plan, which was something you couldn't do before with the services you wrote only in templates. And I think that's a pretty cool feature. And then your definition of not a single line of code, what that means is something else. But not a single line of Erlang, Python, Java, or C, if that makes it easier. But before you had to actually write code to write the plan. Now you just get the plan.
Okay, Simon, anything else? Or?
No, I'm good.
Okay, very good. Hey, so
Cisco, the bridge to possible.